Hello everyone and welcome to another simple science video where we aim to explain simple scientific concepts. And in this video we are going to deal with free falling. So what is free falling? Free falling is when the only force acting on an object is its weight. So for example, if an object falls through a vacuum, if the earth was a vacuum and the only force acting on it was its weight, then it would be considered as free falling. In truth, when something is falling through the air, it is not free falling because there is another force acting on it, and that is air resistance. But often we assume that there is no air resistance in these flights. So we are going to assume that falling through the air, well, not really, falling, most of the time we are going to assume that it is free falling because there is no air resistance, because we are assuming there is no air resistance. Okay? So for something to free fall, it can be launched upwards, thrown downwards, or dropped. And it must be in a no air environment where the only force acting on the object is its weight during its path. So therefore it is free falling, okay? And since weight is the only force acting on the object in its path, its acceleration would be constant. So we can assume that it is an example of uniform acceleration. And as we have described in the previous video, as it is a uniform acceleration, we can use Suvat equations to model their motion. So I'm going to remind you of the three Suvat equations I want you to remember. There are more, of course, but these are the principal ones that you can derive the other ones from. So to remind you, the value of acceleration we are going to use for free fall is g. It is the acceleration of free fall, or 9.8 meters per second squared. So it's the value of a you see in these Suvat equations. And it's very important to know whether g is positive or negative. So if we take upward motion as positive, which is very common, we're going to assume we're going to make g negative because it's against upward motion, because g is always going downwards, or more like going to the core of the earth. But if we take downward motion as positive, then we can take g as positive because it's in the direction of the motion, which is downwards. Now let's get to some examples. A ball is launched upwards velocity of 20 meters per second. What is its velocity after free falling for 5 seconds? So we write out Suvat, and then we write in what values we do know. So it is launched upwards, so u is 20. V, we're trying to find out that. A is minus 9.8, minus because it's against upwards. And if we're considering 20 meters per second as upwards, then we make it plus, and acceleration is downwards because g is negative. It's going downwards. And t, the time of the flight, is 5 seconds. So uvat, we have an equation that we can use to model its motion. So we can plug in the values, and we should get 29 meters per second. And it's a minus 29 meters per second, so therefore it is 29 meters per second downwards. Okay? So the next example is when a ball is dropped and free falls from a height of 100 meters from the ground. Calculate the time taken for the ball to reach the ground. So similarly, we are going to write Suvat, and we are going to plug in what values we do know. So we know S, U, A, and T. So we have an equation for that we can equate all the values. Is S equals UT at half AT squared. And you can plug in all the values. You get 100 equals 0, add half GT squared, basically. And you further improve this, and you get T squared equals and you do the square root of that value, and you should get 4.52 seconds. Okay, very simple. It is another example of Suvat equations, that's all. Now the last example is when a ball is launched with an upward velocity of 40 meters per second, find the displacement of the object when its velocity is 50 meters per second downwards. So you see here there are two velocities, the initial and the final velocity, and they are in opposite directions. So one must be positive and one must be negative. So upwards, I'm going to say that it's positive. Downwards, I'm going to say that it's negative. So we write Suvat to see what values we do know. So S we don't know s. We know u is 40 meters per second, and v is minus 50 meters per second. A is negative g. Remember, it's u and v must be different signs because they're in different directions. And 50 meters per second is in the same direction as g because they're both downwards. So we do have an equation for that. That's v squared equals u squared at 2as. We are going to rearrange to get s, and then we're going to plug in our values like so. Very simple. And you should get negative 45.9 meters. In other words, it's 45.9 meters below the original point where we launched the ball. Okay? Thank you for watching.